So we are starting matrix, and today we'll do first exercise. So first we have to understand the concept. So that concept first we'll know actually what is matrix, how we can form a matrix, what is order of matrix, and when we can say two matrices are equal. So these are three things today we'll discuss. So just I'm showing this video. So if you have laptop, you will use laptop. It will be more helpful. If you don't have, no problem. But if you have laptop, you can use. Okay. So
Mama, your voice is breaking.
wait. Someone is joining, I think. No. Okay. So I'm showing this video. Just observe.
By now, I'm sure you know that in just about anything you do in life, you need numbers. In particular, though, some fields don't just need a few numbers, they need lots of them. How do you keep track of all those numbers? Well, mathematicians dating back as early as ancient China came up with a way to represent arrays of many numbers at once. Nowadays, we call such an array a matrix, and many of them hanging out together, matrices. Matrices are everywhere.
That means what is actually matrix? The rectangular array of numbers or functions. Okay. Okay. So when we'll arrange numbers or a function, that is called matrices or matrix.
They are all around us, even now in this very room. Sorry, let's get back on track. Matrices really are everywhere, though. They're used in business, economics, cryptography, physics, electronics, and computer graphics. One reason matrices are so cool is that we can pack so much information into them and then turn a huge series of different problems into one single problem. So, to use matrices, we need to learn how they work. It turns out you can treat matrices just like regular numbers. You can add them, subtract them, even multiply them. You can't divide them, but that's a rabbit hole of its own. Adding matrices is pretty simple. All you have to do is add the corresponding entries in the order they come. So the first entries get added together, the second entries, the third, all the way down. Of course, your matrices have to be the same size, but that's pretty intuitive anyway. You can also multiply the whole matrix by a number called a scalar. Just multiply every entry by that number. But wait, there's more. You can actually multiply one matrix by another matrix. It's not like adding them, though, where you do it entry by entry. It's more unique, and pretty cool once you get the hang of it. Here's how it works. Let's say you have two matrices. Let's make both of them 2 by 2, meaning 2 rows by 2 columns. Write the first matrix to the left, and the second matrix goes next to it and translate it up a bit, kind of like we're making a table. The product we get when we multiply the matrices together will go right between them. We'll also draw some grid lines to help us along. Now, look at the first row of the first matrix and the first column of the second matrix. See how there's 2 numbers in each? Multiply the first number in the row by the first number in the column.
So try to understand.
1 times 2 is 2. Now do the next ones. 3 times 3 is 9. Now add them up. 2 plus 9 is 11. Let's put that number in the top left position so that it matches up with the rows and columns we used to get it. See how that works? You can do the same thing to get the other entry.
So listen, if you are adding two matrices, then you can add corresponding element of that two matrix. And one thing you remember, if order of both the matrices are same, then we can add. And in case of multiplication also, I'm showing you. I'll give all the concept of when we can multiply two matrices, when we can add two matrices. Okay, all these concept I'll give to you. So here when you multiply, then first row you will multiply with first column. So 1 into 2 is 2 and 3 into 3 is 9. So 9 plus 2 how much? 11. Then you will get first element. Okay. Now, yes,
Matrices.
sir.
Negative 4 plus 0 is negative 4. 4 plus negative 3 is 1. Negative 8 plus 0 is negative 8. So, here's your answer. Not all that bad, is it?
This is the multiplications of two matrices. When we multiply two matrices, then we can multiply like that.
There's one catch though. Just like with addition, your matrices have to be the right size. Look at these two matrices. 2 times 8 is 16.
Just wait, what happened? Okay.
3 times 4 is 12. 3 times... Wait a minute. There are no more rows in the second matrix. We ran out of room. So, these matrices can't be multiplied. The number of columns in the first matrix has to be the same as the number of rows in the second matrix. As long as you're careful to match up your dimensions right, though, it's pretty easy. Understanding matrix multiplication is just the beginning, by the way. There's so much you can do with them. For example, let's say you want to encrypt a secret message. Let's say it's math rules. Though why anybody would want to keep this a secret is beyond me. Letting numbers stand for letters, you can put the numbers in a matrix and then an encryption key in another. Multiply them together and you've got a new encoded matrix. The only way to decode the new matrix and read the message is to have the key, that second matrix. There's even a branch of mathematics that uses matrices constantly called linear algebra. If you ever get a chance to study linear algebra, do it. It's pretty awesome. But just remember, once you know how to use matrices, you can do pretty much anything.
Okay, so this was the little bit concept you understood. Now one by one I am discussing, then you can understand the meaning of matrices. So now matrices will start. Okay. So write the definition of matrices. So number one concept. So first concept of matrix definition. A matrix is an ordered rectangular array of numbers or functions. Like suppose A equals to 2, 5, 7, 3, 2, 5. Okay. One more example take. B equals to sine x minus cos x 1 0. That is also a matrix. Either number we take or we'll take any functions. Now what is order of matrix? Second, order of matrix. A matrix having m rows and n columns is called a matrix of order m cross n. Now how we can write a matrix whose order is m cross n? So its element is representing by small letter Aij m cross n. So if we'll expand this, then we'll write like that. The I is row number and j is column number. So first element will be A11. It means this element lies in first row and first column. Then A12, A13, then A1. How many columns here? N. Right. Then second row can be written as A22, 21. Then A22, A23, A2n. Like that. Last row will be AM1, AM2, AM3, AMN. So if m rows and n columns, okay, in expanded form we can write like that. And here A11, A12, A13, all are the elements of that matrix. Okay, is it clear?
Yes, sir.
Okay, fine. Now, next concept. Fourth. When we can say two matrices are equal. If order of fourth type of matrices I am explaining. Types of matrices. So first is column matrix. Column matrix. A matrix having only one column. A matrix having only one column is called column matrix. Example like A equals to 2, 3, 5. Only one column. Okay. Row any A row number will be anything, either 1, 2, 3, 4, 5, whatever, but column will be only one. Then that matrix is called column matrix. Now, row matrix. So what is row matrix? A matrix having only one row is called row matrix, right? Example, A equals to only one row, 5, 3, 2, 4. Only one row, but column, how many? 4 columns, but row only one. This is called row matrix. Now see. Now square matrix. What is square matrix? A matrix having same number of columns and rows is called square matrix. Example, like A equals to same number of row and column, 2, 3, 5, 4, 2, 1, 7, 3, 2. So number of rows here 3 and number of columns 3. So it is square matrix, right? Then fourth is diagonal matrix. Now fourth is diagonal matrix. A square matrix
These all are square matrix only.
is a diagonal matrix, scalar matrix, identity matrix, all are the square matrix. So a square matrix B equals to Bij M cross M. M cross M is said to be a diagonal matrix if all its non-diagonal elements are 0. Okay, it means what? What is diagonal element? Suppose A equals to A11, A12, A13, A21, A22, A23, A31, A32, A33. This is 3 cross 3 matrix. So diagonal elements diagonal elements are what? A11, A22 and A33. That means if row number and column number are same, that is called diagonal matrix, right? Okay.
Yes, sir.
So I hope you understood diagonal matrix. Acha.
Yes, ma'am.
So
Understood.
this is the diagonal element I explained. Now what is diagonal matrix? Okay. Now consider A equals to, suppose B equals to 1, 0, 0, 0, 5, 0, 0, 0, 3. Each diagonal matrix. Why? Because diagonal, non-diagonal, all elements are 0, right? So all non-diagonal elements if 0, then this is called diagonal matrix. Now fifth. Now scalar matrix. Scalar matrix. Now scalar matrix is a one type of diagonal matrix. Only condition will be all diagonal elements will be equal. So a diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. Diagonal elements are equal. And we know that in case of diagonal matrix, non-diagonal elements will be 0. Right? So a diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. Like one example, take 5, 0, 0, 0, 5, 0, then 0, 0, 5. So clearly all diagonal, because these three are the diagonal elements and all diagonal elements are equal. So it is a diagonal matrix. Now this next one, sixth, identity matrix, right? So identity matrix is one kind of scalar matrix. Only diagonal elements will be 1. So a scalar matrix is said to be an identity matrix if its diagonal elements are 1. That means I2 will be 1, 0, 0, 1. 2 cross 2 identity matrix. I3, it is 3 cross 3 identity matrix. 1, 0, 0, 0, 1, 0 and 0, 0, 1. All are the identity matrix. And last one, is 0 matrix. Then 7th.
Mama, I1 going to be only 1. In case of I1, that is 1
I1
only.
I1 only 1. Now 0 matrix. From name you can understand all elements will be 0. A matrix having all elements 0 is called 0 matrix. So here it is not required, it will be a square matrix or other type. So 0 matrix will be represented by O or dark O. Okay. So this is equals to like 0, 0, 0, 0, 0, 0. Right. So it is not actually 0. It is not number 0. It is dark O. Or you can give one bar. Okay. Because a matrix is a one kind of figure. It has no value. Alright. So this is 0 matrix. So it was the types of matrix.
Mama,
Now,
0 matrix is not a square matrix.
Not necessary. If square and not square doesn't matter. But if all elements are 0, then we can say that that matrix is 0 matrix. Now, equality of matrices. Next concept. This will be.
Sir, can diagonal elements be 0?
Diagonal elements, which matrix? 0 matrix.
Sir, no, in diagonal matrix.
In diagonal matrix.
Yes, sir.
It may be because diagonal matrix condition is non-diagonal elements will be 0. Okay. If diagonal elements 0, then that means 0 matrix, 0 is square matrix, we can say also a diagonal matrix. Right.
Okay, sir.
Now, equality of matrices. Fifth, na? Equality of matrices. When we can say two matrices are equal. Okay. So two matrices A equals to Aij and B equals to Bij are said to be equal if number 1 they are of the same order. They are of the same order. And number 2 condition, corresponding element will be equal. That means Aij should be equals to Bij. Then we can say two matrices are equal. Is it clear?
Yes, sir.
Okay. So this was the concept of 3.1, exercise 3.1. Now, we'll start exercise 3.1. So answer 1. Matrix A is given. What is the order? Who will tell? What is the order of this matrix? How many rows and how many columns?
Mama, 3 rows and 4 columns.
So 3 cross 4. This is the order of this matrix. Number 2, number of element. So 3 and 4 will be multiplied. How many number
12.
elements? 12. Then third, write few elements they are asking. Write A1, 3. So which element present in this position? First row and third column. Which one?
Sir, 19.
19.
19. Very good. Then A21. Second row, first column. Which element?
35.
35. Very good. Then A33. Third row, third column. Third
Minus
5.
minus 5. Good. Then A24. A24. Second row, fourth column.
12.
12.
Then A23. A23. Second row, third column.
5
5 by
by
2.
5 by 2. So easy. Right. Now, answer 2. So I'm recording also, then this video also you will get, so you can repeat and you can make notes. If a matrix has 24 elements, then what are the possible order it can have? Okay, so total number of elements 24, right? This is the number of elements. So possible order will be possible orders are 1 cross 24, 24 cross 1, then 2 cross 12, 12 cross 2, 3 cross 8, 8 cross 3, 4 cross 6, 6 cross 4. Okay. So for all the cases, we are getting number of elements 24. Yes or no? Now what about
Yes, sir.
if 13 elements? If 13 is the number of elements. Number of elements if 13. Then possible order will be possible ordered are 1 cross 13 and 13 cross 1. Right. Now question number 3 I am giving as homework. Question number 4. Now answer 4. One question I am showing, other 2 you will do. Construct 2 cross 2 matrix. That means A equals to 2 cross 2 matrix you have to construct. That means A11, A12, A21, A22. These are the elements. Now condition is given Aij equals to I plus j whole square upon 2. Now follow this and find all the elements. A11. That means value of I is 1, j is 1. So 1 plus 1, 2, 2 square is 4. 4 by 2 equals to 2. A12. 3 square is 9, 9 by 2. A21 also 9 by 2. A22. 2 plus 2, 4. 4 square is 16. 16 by 2 equals to 8. Therefore, you will not leave like that. You have to write that matrix. So A equals to 2, 9 by 2, 9 by 2, 8. So this is our answer. Second, third, and question number 5 you will complete by yourself. Okay, any doubt? Anyone?
No, Mama.
Okay,
No, sir.
so easy. Now, answer 6. So, first question, two matrices are equal. We know that if two matrices are equal, their corresponding elements will be equal. Yes or no?
Yes, Mama.
Then you can tell what is the value of x, y, z. So, x equals to 1, y equals to 4, and z equals to 3. Okay, from equality of matrices, we can say. One more I am doing, third. It's third answer. Here it is given x plus y plus z. Then x plus z, y plus z equals to 9, 5, 7. Now compare both sides. We are getting x plus y plus z equals to 9. Then x plus z equals to 5. This is equation number 1. This is equation number 2. Then y plus z equals to 7. This is equation number 3. Now 1 minus 2, what will get? 1 minus 2, if we subtract, then we'll get y. So 4. Then 1 minus 3. Then we'll get x. How much? 2. Then we got y and x put in first equation. Right. So x is 2 plus 4 plus z equals to 9. So z equals to 9 minus 6. So z equals to how much? 3. So x
3.
equals to 2, y equals to 4, and z equals to 3. Okay. Now, question number 7 you will do. Now, question number 8 I am doing. Answer 8. So, A equals to Aij is a square matrix if what?
M is equal to N.
C M equals to N. This is the condition for equality of matrix. And then answer 10. A number of all possible matrices of order 3 cross 3 with each entry 0 or 1. How many matrices you can make? 3 cross 3, we know that. How many elements? 9 elements.
Yes, Mama.
Right. And each elements can be arranged by two ways. Either you can put 0 or 1. Try to remember permutation. Okay. Number of elements. Number of elements, how many? 9. And each element can be arranged by two ways. You understood? Either you can put 0 or 1. So total number of permutation will be 2 to the power 9. So 512. It means total 512 types of matrices with the help of 0 and 1 we can make. So answer is D, 512. Right? I hope everyone
Yes.
have understood.
Yes, someone
So this
discussed.
was our
Yes, sir.
3.1 exercise. Okay. And next class we'll do 3.2. Okay.